Okay, good afternoon. My name is Angelica Pelegrino, and I am a PhD student from Polytechnic di Bari, Italy. And today I will present this first part of a research that I'm conducting with a professor from Istanbul, Professor Mesut Dural from Fatih Sultan Mehmet University in Istanbul. And the main topic of this research is the perception of comfort in Earthen architectures. Raw art is one of the oldest building materials in human history, yet it's extraordinarily contemporary. It represents the very essence of sustainability and circularity, being a fully recyclable zero-kilometer material with extremely low embodied energy. Beyond its ecological footprint, Earth stands out for its technical and aesthetic versatility. However, despite the objective qualities, the material still faces a deeply rooted cultural bias that associates it with rural backwardness or fragility. The core challenge of this research is to understand how the evolution of architectural design can unlock the true sensory potential of raw art, shifting the user's perception from a poor material to a new standard of contemporary psychological comfort. To address our research question, the study follows a four-step workflow. First, we mapped the existing literature to identify the subcomponents and variables that define comfort. Second, we selected our case studies. Third, we translated the theoretical variables into structured survey, which was deployed as a Google form to a sample of 64 respondents. Finally, the collected data underwent statistical processing to evaluate the mean scores and compare the perception of experts against lay users. To delineate a theoretical framework regarding the perception of comfort in architecture, we tried to find a univocal definition of the term, and this need to define the concept of comfort is a current and multidisciplinary methodological challenge. The reference framework adopted in this research is the model proposed by Jacqueline Vischer, which evolves the traditional view of comfort, understood as the absence of physical discomfort, by introducing a hierarchy of three levels of comfort: physical, physiological or functional, and psychological. Physical comfort is identified with the parameters traditionally linked to indoor environmental quality, and it aims to guarantee the user's biological integrity. Its defiance is directly correlated with physical stress and pathologies. Functional comfort refers to an environment's ability to support the user's activities. This condition is guaranteed by variables like quality of light or acoustic or ergonomics. Finally, psychological comfort represents the highest and most sensory level of the hierarchy, aimed at satisfying higher order needs. And these are the three case studies that we choose. The first one is the Baumschulenweg crematorium. It was chosen to represent the concrete building. We choose concrete because concrete is one of the most spread materials used nowadays for construction. Second one is an house built with earth, is a contemporary house, while the third is the Anandali Center, and this is, as the previous one, built with earth, but with traditional techniques and also with a vernacular appeal. And starting from literature, we have built a survey that consists in 75 questions, 25 for each building. And the answers were based on a 5-point Likert scale, ranging from strongly disagree to strongly agree. And these are the 25 questions divided into categories. And the sample included 64 participants, divided into two balanced groups. And there are 31 experts, including architects, engineers, and senior architecture students. On the other side, there are 33 non-experts, representing lay users and the general public. Comparing these two groups is essential to understand whether academic training changes how a material is perceived, or if certain cultural biases are universally shared. Moving on to the statistical analysis of the result, this slide presents the independent sample t-tests conducted to evaluate whether the differences in attitude between expert and non-expert are statistically significant. The first test compares the attitudes towards traditional Earthen samples. Here we found a statistically significant difference between the two groups. Actually, experts rated it with a mean score of 75.77, whereas non-expert dropped to 66.30. This proves that the users suffer from a cultural stigma regarding traditional art forms, whereas experts possesses the academical tool to overcome this prejudice and appreciate the project. Second test regards contemporary Earthen samples, and both groups gave high scores, with a p-value of 0.31, meaning there is no statistically significant difference between the two groups. And this proved that contemporary design dismantles the cultural bias, aligning the perception of lay users and with experts. And finally, the third test analyzes the contemporary concrete samples. The p-values here is 0.40, and so this is also not statistically significant, showing the acceptance of industrial modern material. In conclusion, the t-test mathematically validates our thesis. The sociocultural barrier towards raw art is real, but it's tied to vernacular forms. Contemporary architectural design can neutralize this bias, bridging the gap between experts and non-experts. In this slide, there are the result of a repeated measure ANOVA, focused on the expert who guaranteed the highest preference to contemporary Earthen samples, followed by concrete and traditional earth. The preference towards contemporary earth is highly statistically significant when compared to both concrete and traditional earth. Contrariwise, there is no statistically significant difference between how experts perceive traditional earth and contemporary concrete. And this shows that while non-expert rejects traditional earth, experts evaluate it placing on the same value as concrete. In this slide, we can see the repeated measure ANOVA, but focused on non-expert, and actually they gave the highest preference to contemporary earth architecture, followed by concrete and then traditional earth. And this is highly statistically significant and confirms that geometry universalized the appeal of raw art. The comparison between traditional earthen architecture and concrete is highly statistically significant. Non-expert underrates traditional earth when compared to the concrete. This chart reports the performance for each building comparing expert and non-expert. It emerged that non-expert gave lower rating to the question linked to psychological comfort, revealing a sense of distrust toward vernacular forms. But groups gave high rate to question linked to psychological comfort in contemporary architecture. In the concrete sample, experts show a high psychological appreciation, while non-experts don't. And this confirms that architectural training acts as a filter that values concrete, whereas lay users perceive it as a cold or alienating. In conclusion, we want to emphasize that this research is still at its initial stage, and however, we believe it establishes a methodological framework for the future. This study offers a tool to navigate the complex perception of raw art, and it allows us to map out where user biases exist, understand which architectural form trigger this negative reaction, and identify how contemporary design can resolve them. Ultimately, it demonstrates that changing the future of art and architecture is not just a matter of engineering, but a matter of design language. Contemporary architecture is the vehicle that can transform a perceived material stigma into a universally appreciated sensory experience. Thank you for your time.